All right, we are starting science. We are going to talk about motion, which is on page 132 of your textbook. So open up 132 in your textbook. That is your manual, but you can open up to your manual as well on page 105 in your manual. And 105 in your manual, page 132 in your textbook, which talks, they're playing baseball. Who has ever heard of the man Sir Isaac Newton? He was a famous scientist. And he had 3 laws of motion. And motion is what we are talking about. What is motion? Jack?
Something that moves.
It moves. So motion is a change of position. How can something change position? Let's say a ball is rolling. How is it going to change? What is required to change the direction or the position of where it's at? We talked about it yesterday. Tyson?
Friction.
Friction is what's going to slow it down. But that's correct. That's going to slow it down. So friction will slow it down. What is going to change? What's going to be a requirement to get it to change? What if I kicked it? Is that going to change the position of the object? What is that? If I kick something, that is what? What is that? Jonathan?
Force?
Yes, force. In order to move an object, it requires force. So Sir Isaac Newton formulated 3 laws of motion. The first law of motion states that an object tends to stay at the same speed and direction until a force causes it to change. So again, if I'm going to use our fluffy pom-pom. So it's moving, and then I kick it and it goes another way. Would it go over there if I didn't kick it?
No.
That was force. So the ball is going to go, the same speed, the same direction, until some form of force changes its direction. It could be a kick, it could be a shove, it could be a pull, it could be a hit, a headbutt. If you're playing soccer. So, force. Think of force as something that is changing the position or the speed of an object. The second law of motion states, I hate wearing glasses and wearing masks, that the applied force is equal to an object's mass. What is mass? What is mass, Jeremiah?
Something that takes up space.
Yes.
Water.
So applied force is equal to an object's mass multiplied by its acceleration. Clearly you don't have to know this, so don't worry. It's not going to be on your test, but it's interesting. The greater the mass of the object, the more force is needed. So is there a lot of force needed to move this cute little puppy ball? No, because it's got very little mass. It's very small. Now, if I had an elephant in the room, would it be very hard to move the elephant?
Yeah.
Why? Helen?
It's very heavy.
It's very heavy. It has a lot of mass. Easy to move. Elephant, not easy to move because it has more mass. So if you envision something small is easy to move. This is easy to move. Sorry, Daisy. An elephant is not. I could not take an elephant and do a little hit like that and it's going to move. He's going to look at me like, what is your problem? Right? Because it's not going to move. The third, the law of action and reaction. What is action and reaction? What does it mean to react? Bless you. You react to something, what does that mean? Jack.
The,
Jonathan.
like, you're acting what's happening.
Has anyone ever seen one of those toys that has a string with metal balls on it? And there's a series of them, and then you take one of the balls and it makes all the other balls move, and then they move back.
Yeah.
And it's action, reaction. So what Newton is saying is when one object exerts a force on another object, the second object reacts by exerting an equal force back. So if you envision those balls, did everybody get this written down?
Yep. Yeah.
Does everyone envision what I'm talking about?
Yeah.
It's kind of a fun, I don't know, for some reason it's kind of fun to watch, very simplistic. So basically what we have something that these strings are suspending from.
Like a piece of wood?
Yeah, a piece of wood, piece of metal. And then these are strings, and each string has a ball at the end.
And then it makes noise.
It does, it makes a nice little clicking noise. So if I were to take this ball and move it this way, and then let it go. So I pulled it up, and then I let it go. Is it just going to go back to this position?
No.
It's going to hit this ball, which in turn is going to hit this ball, this ball, this ball. And then is it going to stop?
No.
No, it's going to swing out, and then it's going to swing back. And then we're going to go all the way through again. Action, reaction. Action, reaction. So what Newton is saying is that if you have, these are all equal sizes, equally spaced, and they have the same amount of mass. So they're equal in every way. So with that action, you're going to get an equal reaction. What if it looked like this?
Whoa. Whoa. No.
Is that going to work?
No.
Why? Why is it not going to work? Is it going to have an equal reaction? You're probably going to have a reaction because when I swing this big baby up, it will come back and it will, because the top part will probably hit that. But is it going to be equal? Because they're not what? The same
Size.
So equal. The key is equal force back to the first object. It's got to be equal. So reaction versus, or action versus reaction. All right, so we talked about action and reaction. We talked about, don't worry, you're not going to have to know the Sir Isaac Newton formula. It's just kind of interesting of the three laws of motion. But it's interesting because I should know, but I don't know when he was living on Earth, but it was a very, very long time ago. And his law and his hypothesis is still true. So, with that said, what is going to cause a motion to change its position? What is going to cause a motion to change its position. We talked about that. I'm going to hit it. I'm going to kick it. I'm going to shove it. What is that? Jack?
Force.
Yes.
Can I also sharpen my pencil?
Yes. So, open to, well, let's read a little bit more about motion. We got a fun little baseball game going on. Yeah. So, read on page 133. What does it say underneath? Do you guys have that? I want to just check because sometimes, yes, no. So underneath each of these little people, there is something said. Jonathan, what does it say with the picture? Picture's right here. What does it say underneath the picture?
Motion can be described by what direction an object travels.
All right, so where's my fuzzy ball? Oh, Daisy has it. So, bless you. I would love to be able to throw it to you, but I can't. So,
I can hand sanitize.
no, I can't. As tempting as it is. So, let's say I throw it this way, or I throw it this way. That is describing, so if I throw it that way, that is the direction it's going. Goodbye, ball. If I were throwing it straight, that is the direction I'm throwing it. So the direction is described, motion can be described by the direction. Hello. Please read, I don't know, is that, I don't know what, is that third, let's see, for second base. What does it say by second base? Owen.
Motion can be described by how far an object travels.
So if I threw it from here to the swing sets, that'd be impressive. I cannot. Trust me.
What do you say?
If I could throw those from here to the swing set,
Unless it's
that would describe how far the object could travel. Who wants to read the outfield? Jack.
Motion can be described by how fast an object travels.
So motion can be described by how fast, how far, and in what direction. Speed, distance, and direction. That is describing motion. So the baseball can travel different distances. It might travel far into the outfield, or it may go only a few meters in front of home plate. If you measure from where the ball was hit to where it was stopped, you know the distance it traveled. The baseball can also move at different speeds. How can the baseball move at different speed? What is faster? Hitting it with a baseball bat or throwing it? What is going to be faster? Ella?
Hitting with the bat.
Yes. Is it also going to be, is the baseball bat versus throwing going to affect the distance?
Yes. Yes.
For the most part, depending on the hitter. Now, if I'm hitting it, you might be able to throw it further than I can hit it. But if you get a professional baseball player who hits a home run versus somebody throwing the ball from pitcher to third base, that's a significant difference in distance, correct? And you can describe motion of an object. Okay, when a baseball is hit, its motion changes. So let's say I'm a batter, and as a batter, can I change the direction that I'm going to hit it?
Yes. Yes.
Yes. Personally, I couldn't, but there are players who can change the direction of a ball by how they hit the ball with the bat, correct? You have to be very good. My problem is I'm afraid of the ball. So I am not good at baseball. When I was probably your age, my brother pitched the ball and it hit my nose and I was done. Never liked it since. So what are the three parts of motion. The what? Owen, what is one way to describe motion? The direction. Jack.
Where it travels?
Where it travels, the distance it travels. And what is the third? M.
How fast?
Yes, the speed. Open your study guide to 105. Number 6 is what you just answered. What are the 3 ways to describe the motion of an object? The direction it travels, the distance it travels, and the speed it travels. So those are the 3 ways to describe motion. I do love this puffy ball. It's very squishy.
What about the black one?
The black one is not as squishy, but it's very soft. So that is therapeutic in a different way. But yeah, this is nice and squishy.
Where is the black ball?
What's that?
It could be your mini pillow.
My little mini pillow. This could be a Mia pillow.
That's Mia's pillow. That's Mia's bed.
That's Mia. That'd be like
That's Mia's bed.
Daisy's head is probably bigger than Mia.
Daisy.
All right. What a force is a what or a what? We talked that on the first day. What is that? Raise your hand, please. Olivia.
Push.
Yes, and then what is this? Remember Tyson and I did it with the ribbon. Jack.
Pull.
Yes, that is number 1.
Into.
Owen. Not right now. Number 2, objects cannot move unless it's what? Unless a blank causes them to move. What? That's the ball. What needs to happen for that ball to move? Jeremiah.
You need to throw it or something?
I do, but what is that called? When you exert what onto that object, it's going to move.
Force.
Yes, very good. So a force can make an object go 3 different ways. It can make it go what, or blank direction. So depending on the force, if it's a little force, little teeny tiny force like this, or a big force. So it can make it go what? If it's a big force, it's going to go what? Faster or slower? If the force is a big force, exerts a lot of force onto that object, is that going to make the object go faster or slower? Jonathan?
Faster?
Yes. So, I am going to, okay, it went fast until it what? Hit the sanitizing station, and then it what? Stopped or slowed down. So when a force meets an object, it's going to either stop or slow down. So if the force is a big force, it's going to go fast. When I say force, envision something hitting it. So if I am, let's say the ball is floating in the air, and I hit it, and it changes motion, right? Go la 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 la. What is that force causing this ball to do? Floating, 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 hitting it. What is it? Changes what? Floating, 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 and then hit it. And it goes what? A different Schwinn. Yes. So an object A force can make an object go faster by exerting a lot of force on it, like kicking the ball. It's going to go fast. So if that ball then hits some sand and there's friction, it's going to what? Jonathan,
Slow down.
slow down. And then if the ball, if we're in a soccer game and somebody kicked the ball, but then somebody else kicked it another way, what is that going to cause the object to do? Change what? Owen, direction. So if I am kicking the ball and I keep doing this, what direction is it going? Straight. So if the force is moving the object the same, an object moves in the same direction as the force that makes it. So if you're playing soccer and you're kicking the ball down the field, to me soccer is a perfect example. Kicking it, and you're going, kicking the ball, keeps going straight until somebody comes and kicks it away from you. And then it changes direction. That is a force. Are you getting that? That's important for you to understand that the force can either make you go straight, the same direction. If you keep kicking it the same direction, the ball is going to keep going the same direction until another force makes it change direction. Ooh, I think we're all tired.
Oh, yeah.
Too much pizza.
Oh,
All that pizza
I want to relax.
is working in your body, making you tired.
I need to relax.
That's all right, because we are done. So what you're going to do is you're going to finish. So number 4, an object moves in the same direction as the force that moves it. Does that make sense?
Yeah.
Envision soccer. You're kicking. The ball's only going to go the direction that you're kicking it, correct?
Yeah.
Ball doesn't move on its own. It's like sees you like, I'm going to move. No, it's going to go the direction in which it kicks. It's kicked. All right, we conclude for the day.